Alright, today I'm going to be doing my final project problem for Calculus 1, which is fx equals xe to the negative x. Now first I have to realize that these are two functions, x and e to the negative x. So I'm going to bring down the negative exponent right here, so it's going to be x over e to the x. And then now I can use the quotient rule to find with the first derivative to find the first derivative. So we have f prime of x equals, I'll write the quotient rule out, quotient rule which is gx times f prime of x minus fx times g prime of x over gx squared. With each of these, this x being fx and this is gx. So right there and right there. So now when we plug in these values to the quotient rule formula, we get e to the x times the derivative of fx, which is x, which is 1, minus x times the derivative of ex, which is ex, all over ex squared. Now after we found the quotient rule, we're going to take the top of this function and use it to find a critical point on the graph. So I'm going to set the top of this function equal to 0. This is ex minus x e to the x. So I set this equal to 0, and now I'm going to solve for what this function is, what makes this function equal to 0. So I'm going to bring the ex over to this side, so I get negative ex equals negative x ex. Now I can divide these ex's, this ex across, which leaves me with negative 1 equals negative x, which means x is equal to 1. Now I know this, the point on the graph, which is a critical point, is at x equals 1, 0. So now that I've found the critical point, I'm going to plug in numbers below and above this point using the first derivative test to find out where the function is increasing and decreasing on the graph. So I'll choose negative 1 for my first point. So f prime of negative 1. I'm going to plug this value in. So it's e to the negative 1 plus e to the negative 1 all over e to the negative 1 squared, which leaves us with 2e actually. 2e to the negative 1 over e to the negative 2, multiplying the exponents out. And now we're going to bring these negative exponents down to the bottom. So it's 2 over e divided by 1 over e squared. And then multiplied by the reciprocal to find, so it's 2 over e times e squared over 1, which leaves us with 2e, which is positive. So this means that the values, for all the values below 1 are increasing. So now we're going to use the first derivative test to test the values above 1. So I'm going to do f prime of 2, and I'm going to plug these in. So I'm going to get e squared minus 2e squared over e squared squared. And with this, I'm going to get e to the 2e to the fourth, no, negative 2e to the fourth. And I'm going to get negative 1e squared, there we go, all over e to the fourth. And that's what I was getting the fourth from. Alright, so now that I have this, we only have one negative, so we don't even need to solve this out. It's just negative e squared over e to the fourth. So there's one negative, so this will always be a negative value. So now that means that values above 1 are decreasing. So you have positive and negative, so I'll show this on a number line. We have plug our number, we have 1 and negative 1. And then 2. So that means that we plugged in negative 1 and the values up to 1 are increasing, and then the values above 1 are decreasing. So writing this out, we can write fx is increasing from negative infinity to 1, and fx is decreasing from 1 to infinity. And now that we found that it's increasing and decreasing, we can determine that this is x equals 1 is a local maximum. So we can write local max equals x equals 1. All right. So now we found our points, we found our local maximum and where our function is increasing and decreasing. Awesome.